SAMMY, and I'll be talking about interfaces today. So the title is, as you can see, Unveiling the Power of Interfaces, Go Secret Weapon. It's not so secret, but yeah. So we'll do a bit of a deep dive into how interfaces in Go work and how they differ from other languages. Okay. So a bit about myself. I'm a technical lead at Ultraviolet. We work on confidential computing. We have some open source projects as well, so you can check them out. You can see my GitHub or follow on X. Yeah. So let's start. What is an interface? I think everyone here has faced that at some point, or maybe not, but an interface basically defines a set of methods with their signatures. And in Golang, this is implemented implicitly. What does this mean? It means you don't have to say, this is an implementation of this interface. The satisfaction of the interface is by having the structure. Just by having the same structure that is defined in the interface, you've implemented it. So as you can look at this example, we have an example of a string interface and an implementation by this person struct. So person struct has two fields, name and age, and then it implements the stringer method by having the same signature as we have on the stringer interface with string method, which returns a string. And the structure is basic. We have the receiver, and then you do whatever within the implementation of the method. So in this case, we just print this, we return a string that combines the age and name, for example. Okay, so I'm going to talk about the characteristics of an interface in Go. So the first thing it's stated before is this implicit implementation. So we don't have to say explicitly this is an interface. Some other languages have that, as we'll see later. Another thing is with structural typing. What this means is we define what an interface is by what method it has, rather than saying explicitly this implements that. So just by following the same methods and the signatures, then we have our interface implemented. Another thing is the interface satisfaction is determined at compile time. So this is in comparison to dynamically typed languages, for example, Python. So once we define an interface and we're implementing it, maybe it's being called by some function. At the point of compilation, we'll be able to do static type checking to confirm this. So yeah, in comparison to dynamically typed languages. Another thing is we allow zero methods which are valid. Like if you have an interface which has no methods, it's basically satisfied by all types in Go. We'll also see this later. In this interface, we have two types of loggers. We have one logger interface, and then it's being implemented by two structs. So we have a console logger and file logger. So you can have some flexibility here. You can easily change between the logger types that you're using in your code by simply having this interface that can be implemented in different ways. So it makes it very flexible to change your the behavior in your code base without having to do major refactoring. Let's look at another example. Another thing is with testing. So for example, you have some method that is being called within another function. And if it was just a function, then if you're writing a unit test for this, you'll have to make sure this function will work. So for example, if it's a DB call, you need to have the database running. But if you have an interface, we can mock that interface, and then we can um, dictate the behavior during testing. So when this method is called, we can determine something that is returned at that point. So you can look at this example there. Another thing is with plugins. So for example, you're writing some open source tool, and you want to allow users to bring their own kind of behavior. So you can have plugins like, we just defined this interface. For example, in this case, maybe in your main code base, you have this run method. And as long as this interface is applied, you can run, you can work with whatever the user provides. The method can do anything, any behavior they dictate on their end. Let's look more at advanced techniques here. Another thing we can do with Go is we can embed interfaces within other interfaces. So this is kind of extension of an interface. So for example, here we have two interfaces, reader and writer. And then we have read-writer, which will embed both interfaces, the reader and writer. So this read-writer interface will have those two methods, the read method and the write method. Let's look at another thing, which is type assertions. So during running, we can go back from an interface to the type that was used. So we do type assertions in Go. So for example, you have a variable which is an interface. And here we don't explicitly declare it as a string, but you can assert it as a string type and extract that type. Or any other type of variable. Another way to do this is using the switch type, and switch and go through each cases of different variable types. You can do this for your own custom types or goes on types. Another thing is the empty interface, which has no method, so it can be satisfied by any variable type. So you can pass literally anything there, any type, and it will be satisfied for this function. Okay, so next let's do a bit of comparison with other languages, and sometimes not exactly interfaces, but something comparable. Yeah. So for example, in Java, you can see here we have some explicit declaration of, okay, we have the interface, and then we have explicit declaration that this interface is being implemented here. Yeah. So how this differs from Go is we have the implicit implementation in Go. So compared to Go, you'll have in Go you'll have less boilerplate code, and yeah, just makes it easier to use. Who knows what duck typing means? Anyone? Okay. I don't know if you've ever heard of if it walks like a duck, talks like a duck, it's probably a duck or definitely a duck. So what this means is when you have like for example in Golang, if you define an interface and it has these methods, then it definitely implements these methods by having those methods within that struct. And so it's kind of similar in Python. So for example, this print object will work for any class that has the print method. But the difference with Go is This is not checked during compile time. So we have no static checking of the types here. For C#, it's kind of the same as Java. It's a bit more verbose compared to Golang. Yeah. For Rust, it's just about the same as Go. The only difference is how it looks. But you have your trait, which is equivalent to an interface, and you have your struct, which implements the interface. And it's, yeah. The only difference with Golang, I would say, is Go is a bit simpler, but it's very comparable. For Go, we're able to combine the flexibility, and we have type safety as well, and it's easy to use. We also encourage composition over inheritance, so the structure matters. It also allows us to do loose coupling of your code, so it allows you to make changes quite easily. And dependencies can be much simpler there. Another thing is it allows us to write our code that is very modular and easily testable, as we showed in the previous example. And yeah, overall, it just allows us to create what are flexible systems and yeah, quite easily maintainable. Yeah, that's it from me. You can find me somewhere in the hall here or on Twitter or yeah. That's it. Thank you.